Don't you just love math? I sure do. You should too, because it's neat. Alright, we're going to talk about solving inequalities today. Words like at most and at least suggest a relationship in which two quantities may not be equal. You can represent such a relationship with a mathematical inequality. Just as you use properties of equality to solve equations, you can use properties of inequality to solve inequalities. Alright, here's how inequalities look. X is greater than 4. So here's all my x values that are greater than 4. X is greater than or equal to 4. Here's all the x values that are greater than 4, plus the one that's equal to 4. So when you got this little line under, you got to fill in the circle. When you don't have the little line under, you got to leave that circle empty. X is less than 4. Here are all my x values that are less than 4, and I'm not including 4 because 4 is not less than 4. X is less than or equal to 4. Here's all my values that are less than 4, plus the one that is equal to 4. Alright. What inequality represents the sentence 5 fewer than a number is at least 12? So 5 fewer than a number, that's going to be a number minus 5. Fewer indicates subtraction. At least indicates greater than or equal to. That means it could be 12, but it could be more. It's at least 12. So that's greater than or equal to 12. So 5 fewer than a number is x take away 5. And that's at least or greater than or equal to 12. See if you can figure out what inequality represents this sentence. Pause and then push play again when you're ready to see the answer. Alright, the quotient of a number and 3, that's x divided by 3, is no more than 15. It could be 15, but it can't be more than 15. So that means it needs to be less than 15 or equal to 15. It can be 15, but it can't be more than 15. So there you go. X divided by 3 is less than or equal to 15. There's a lot of properties. Transitive property, we've talked about that in previous lessons. These are all pretty much the same properties that we used when we were solving equations. So go ahead and throw those in your notes if you feel the need. What is the solution of this inequality? Graph the solution. Well, it looks like we need to do some distributive property here. I would distribute that negative 3. Negative 3 times 2x is negative 6x. Negative 3 times negative 5 is positive 15. Then I would combine like terms. 15 plus 1 is 16. Now I would subtract 16 from both sides of the inequality. Then divide both sides by negative 6. Now remember, when you divide by a negative, you have to reverse the inequality symbol. So x is less than or equal to negative, or less than or equal to 2. So it can equal 2, and then everything less than that. So pause and see if you can solve this equation, this inequality. Push play when you're ready to see the solution. Alright. I'm going to distribute. Alright. I'm going to distribute negative 2. So that's negative 2x minus 18 plus 5 is greater than or equal to 3. These are like terms. Negative 2x minus 13 is greater than or equal to 3. Add 13 to both sides, and I get negative 2x is greater than or equal to 16. Then I'm going to divide both sides by negative 2. When I divide by a negative, that changes directions, and x is less than or equal to -8. Thought maybe I would have had a number line there pop up for me, but I guess not. There's 0. Call that -8. It's less than or equal to. So I'm gonna fill in my circle because it can equal -8, and less than is to the left. There's my graph. Alright, a movie rental company offers 2 subscription plans. You can pay $36 a month and rent as many movies as you want, or you can pay $15 a month and $1.50 to rent each movie. How many movies must you rent in a month for the first plan to cost less than the second plan? So we're going to assign a variable. I think the variable should be how many movies you rent, right? Let n equal the number of movie rentals. Write an expression for the cost of each plan. So this plan is just 36. This plan is 15 plus 150 times n. The first plan must cost less than the second plan. So we're going to do 36 less than 15 plus 1.5n. Then we solve. Subtract 15 from both sides. Divide both sides by 1.5, and you get n has to be less than 14. N has to be greater than 14. 14 is less than n. So you must rent more than 14 movies in a month for the first plan to cost less. I probably would not be renting 14 movies in a month, let alone more than 14 movies. Let's pause and see if you can figure out number 3. Push play when you're ready to see the solution. Alright, a digital music service offers 2 subscription plans. The first is a $9 membership fee plus $1 per download. So 1 times, we'll call D the number of downloads. The second has a $25 membership fee plus 50 cents per download. How many songs must you download for the second plan to cost less than the first plan? So we want the second plan to be less, and we just need to solve for D. So I got 9 plus 1D is just D, greater than 25 plus 0.5D. I will subtract 9 from both sides. I'll have my D be over here. D is greater than 16 plus 0.5D. Subtract 0.5D from both sides. This is 1D minus a half a D, which means we have another half a D left. Greater than 16. Divide both sides by 0.5. You can use a calculator, or you can say dividing in half is the same as multiplying by 2. I'll prove it. Should be 32. D is greater than 16 divided by 0.5 is 32. So you need to do more than 32 downloads in order for the second plan to be cheaper. Alright, so let's look at this always, sometimes, never business. The way to answer that is to just solve it and see what it looks like. So I distribute and then add 6x to each side, and we get, what do we have left? -2 is greater than 7. That's never true. So that means that this original inequality is never true. So it has no solution. Never true. Here we're going to distribute 10x minus 15. Simplify a little bit. 10x minus 7x is 3x. If I subtract 3x from both sides, I get negative 15 is less than or equal to 8. That's always true. No matter what number I put in for x, this equation is always going to be true. So it's true for all real numbers. So all real numbers are solutions. So pause, see if you can figure this one out, and push play when you're ready to see the solution. Alright, so let's distribute. 4 times 2x is 8x. 4 times negative 3 is negative 12. 8 times x is 8x. 8 times 1 is 8. Now I'm going to subtract 8x from both sides. And I get negative 12 is less than 8. And that is always true. And the secret phrase for this lesson is aloha mora. Aloha mora. Did you know that you can join two inequalities with the word and or the word or to form what we call a compound inequality? To solve a compound inequality containing and, find all values of the variable that make both inequalities true. Alright, so here's a compound inequality. We're going to have to just solve each one independently. And what we did is subtract 1 from both sides and then divide by 2, and we get 3 is less than x, and x is less than or equal to 6. Then we kind of plot both of them. They show them like floating here. X less than or equal to 6 is equal to 6, then it contains everything less than that. X greater than 3 has an open circle at 3 and then everything greater. But the solution to the compound inequality is where these two overlap. They overlap starting at 3 but not including 3, and then going all the way up to 6 and including 6. So you can see this purple region here is where both of these inequalities are satisfied. Alright, pause and see if you can do number 5. Push play when you're ready to see the solution. Okay, I'm going to write up here. 5 is less than or equal to 3x minus 1. I want to add 1 to both sides. 6 is less than or equal to 3x. Divide both sides by 3 to get x by itself, and I got 2 is less than or equal to x. So that's part of it. I'll write it down here using the symmetric property. X is greater than or equal to 2. And now I'll solve the other one. 2x is less than 12. Divide both sides by 2, and I get x is less than 6. Alright, so zero, 1, 2, 3, 4, 5, 6. There's 2. Okay, so greater than or equal to 2 is a solid circle at 2, and then everything to the right. Less than 6 is an open circle at 6, and then everything to the left of that. They overlap right here from the solid circle at 2 to the open circle at 6, and they overlap in between those two. So there you go. This is how you would write the solution, and this is how you would graph the solution. To solve a compound inequality containing OR, you find all the values of the variable that make at least one of the inequalities true. So let's see how that works. So over here, we're going to subtract 7. And over here, we're going to subtract 8. So that gives us k greater than or equal to -1, or k is less than -5. So greater than or equal to -1 is here. Less than -5 is here. And our graph, our final answer, needs to show where either one of those is satisfied. So OR shows both. All right. Pause it, see if you can do number 6. Push play when you're ready to see the solution. All right. So over here, we're going to subtract 3 from both sides. That'll give us 7w is greater than 11 minus 3 is 8. Divide both sides by 7. And we get w is greater than 8 over 7, which is 1 1/7. Or, we're going to add 1 to both sides. That gives us 4w is less than -12. Divide both sides by 4, and we get w is less than -3. Zero, 1, 2, -1, -2, -3. Okay, so greater than 1 1/7. 1 1/7 would be right about here and that away. Less than -3 would be here and that away. So our final solution would show, our graph anyway, would show these values and these values. Boom. And this is the compound inequality, and that's our graph. Over here, we're going to subtract 1, and we get 15 is less than 5x. Divide both sides by 5, and we get 3 is less than x. Symmetric property says that x is greater than 3. Or, subtract 9 from both sides, and we get 3x is less than -3. Divide both sides by 3, and we get x is less than -1. X is greater than 3, so open circle at 3, and then the values to the right. X less than -1, open circle at 1, less than to the left. Citrus. Hasta luego. Do your homework. Hit me up with any questions you have.